So let's define our trigonometric ratios using our Cartesian plane. So let's create a point. We'll see that the Cartesian plane in this case has now been, well, we've added a circle onto the Cartesian plane with O, the origin, as its center point. So let's create a point on our circle. We'll do that at this point here. We'll call that A. And A is, of course, at intersects 3 on the x-axis and 4 on the y-axis. So we have A, which is point 3 and 4. Then our next step would be to join a line from the origin O to point A on the Cartesian plane. And then we'll draw a line down from point A to our x-axis that intersects at the point 3. So we now have our familiar right angle triangle that we use in determining trigonometric functions. So what we'll do is we'll use the angle from the positive x-axis to our line OA. We'll call that theta. And then we can determine the sides of the triangle in relation to our angle theta. So let's write out our SOHCAHTOA mnemonic in order to remember our trig ratios. SOHCAHTOA. Alright, so we can start off with the sine of theta is of course equal to our opposite over the hypotenuse. So we'll need to define the names of the sides of our triangle within the circle. So we know that our opposite side is the length of where our point A intersects on the y-axis. So this will be the length of y. And the same for the point where A intersects on the x-axis would then of course be x. And then because O is the center point of our circle, our length OA would then of course be the radius of the circle. So hypotenuse will be the radius. You'll also note that because this is the origin of the circle, R will be constant all the way around the circle. It will be the same value. So now we can then enter our trigonometric ratios in terms of the sides that we have defined for this right angle triangle. So our opposite side is of course y, and our hypotenuse is r. We can then do the same for sine's reciprocal function, which is of course cosecant, and that is then r over y. Then we need to do our cosine function. So cosine of theta is then equal to the adjacent side, which is x, over our hypotenuse, which is r, and the same for its reciprocal, which is of course secant of theta, and that would then be r over x. And then finally our tangent function would then be the opposite side, which is y, over our adjacent, which is x, and the same for the reciprocal, where we would define it as the adjacent side, which is x, over our opposite side, which is y. Then another interesting thing that we can do using this, using the Cartesian plane, is in determining the length of r. Because of course at this stage we only have the lengths for y and the lengths of x from where they intersect the x and the y axes. So we can use our theorem of Pythagoras to determine the length of r. So r squared would of course be, or the hypotenuse squared is equal to the sum of the opposite squared plus the adjacent squared. So that would be x squared plus y squared. We can then test this for this right angle triangle to make sure that this is correct. So of course our length of x is 3, so 3 squared plus the length of y squared, which would be 4 squared. That gives us 9 plus 16, which is 25. So r would be the square root of 25, which gives us 5. Now remember we said at the beginning that the radius of the circle, because O is the origin or the center point of the circle, our radius is going to be constant throughout the circle. So we can actually go and test this. So where the circle intersects the y-axis, we'll see that that is at the point 5, which says that the length of r is 5. Also the same at the x-axis, and then of course the distance on the negative axis and the y-axis is also of course 5. So we know that our radius is 5, and that then confirms the theorem of Pythagoras, which then says that the radius squared is equal to x squared plus y squared. So let's use this right angle triangle in this example to actually test and determine the size of our angle theta. So let's use our sine function. So we'll say the sine of theta is equal to our opposite side, which is y. We know the value for y is 4, over our hypotenuse, which is of course 5. 4 divided by 5, you can check this on your calculator, is 0.8. So then the sine of theta, we need to algebraically solve this equation to determine the size of the triangle. So we need you to check this on your calculator, but that gives us an angle of 53.13 degrees. So try this for the other functions to test your answer, and that gives us an idea of defining our trigonometric ratios using the Cartesian plane.